Okay, in this tutorial we're going to discuss feeder belt design. Feeder belts are essentially the same as a regular conveyor, only we've got these additional shearing forces to pull out the material. If you haven't watched the tutorials on the feed points and pull-out forces, you want to watch that tutorial because that pretty much describes most of the feeder belt calculations, and we're not going to repeat that here. But you want to watch that one first before you get into the feeder belt design. So I've just went ahead and selected a file, new, and I'm going to go down here and select feeder belt, and we'll just leave it at the default. In fact, let's say that this feeder belt only maybe let's say it's maybe 6 meters long. So we'll have, let's say, a meter back here, maybe a 4-meter slot length, and then maybe 2 more meters of skirting. So go ahead and click continue. You can see we just got a regular conveyor geometry here. Now with a feeder belt, the most important things we're going to want to specify is what is this slot length and what's our skirt length. And Sidewinder is not really it's not going to auto-calculate those for us. I mean, it'll auto-calculate those, but it's essentially assuming that this is a belt conveyor. You really need to refer back to your feeder belt design manuals and whatnot for what kind of lengths you need and skirt board heights or opening heights and so on and so forth. You can enter those values and then Sidewinder will do the calculations for you, but it doesn't really give you a default feeder belt design, not that there is such thing as a default feeder belt design. So what we're going to want to go ahead and do right off the bat is specify what that slot length and what that skirt board length. So we just already said we're going to have a slot length of 4 and a skirt board length of 1. So I'm going to go ahead and enter those before I even do the calculations. You also notice, based on the tonnage and some other things, Sidewinder just defaults to a belt speed of 0.5 meter per second. And then it'll sort of calculate, estimate a belt width for us. But by all means, we can, certainly change either one of those values. If we want to go slower with that belt width, you can see it's going to calculate what the material depth is. And we've got a 1.1 meter of material there. At the 0.5 meter, it had picked the ST1600, which tries to sort of default around a 0.5 meter material height. That's what it's going to sort of default around. But there again, you can enter any belt width or speed that you like. Sidewinder is defaulted to just a single idler, but by all means, if you said, say you had a 3-roll picking idler set, you could certainly enter 3 there, in which case we'd have a custom idler set. And we could specify our center roll length. I'm just going to say, let's make it maybe 80% length. There you go. If you know what your actual center roll length, you can specify that. And your picking roll lengths, you can specify those there. But this is pretty much our loading point tab here, and our loading point information, and our output loading point. This is really the crux of feeder belt design. And as I discussed in the previous tutorial on load points, there's really 2 different calculation methods. One method calculates this yellow or this volume based off of a 75-degree buildup angle here. This material buildup angle. That's just the default. Now you can also change that to whatever you want. The brush method essentially says, okay, look, this buildup angle is 90 degrees and the buildup height is going to be 2.5 times our opening width here. So we've got an opening width of about a meter, roughly a meter. So this height, when we run it, if we put in 90 here and run it, you can see, zoom back there, you can see we've got a square material volume there, which is perhaps much more like a feeder belt design would be designed to. This is a much more conservative type number. If you didn't want to use 2.5 times the skirt board width, you certainly could enter that material cutoff height. But once you calculate that volume, or once you either manually calculate that or you let Sidewinder calculate that, you're going to get a material volume. From that, you're going to know your vertical load. From that vertical loading, you can then calculate your material, the shear force, based off of your internal friction angle. So in feeder belt design, you really should know what your material properties are. This friction angle, if you click over there, you can see that those pull-out forces are simply calculated the vertical load times 0.8 times the sine of this internal friction angle. So this friction angle is very important. Sidewinder will default to 18 degrees more than the surcharge angle, but again, this friction angle is something it's its own material property. We relate it to surcharge angle just as a estimate if you don't enter anything, but you should really be able to look up that value just like you look up bulk density or surcharge angle or any other basic material properties. You should be able to look that up in a book or get that measured in a lab or whatnot to calculate that volume or that friction. Surcharge angle, which in turn obviously equates to a coefficient of friction. You can see right there 0.8 times the sine of that angle is essentially the equivalent coefficient of friction times your normal force gives you that material shear pull-out force. So that's pretty much it for feeder belt calculations. All the rest of the pulley drag and return idler drag and all the rest of the calculations are done in the same manner. A lot of times feeder belts will have a hydraulic coupling for the motor type. Again, so if we've got a tutorial on the different motor types, you might want to watch that one first. But on a lot of feeder belts, you actually have a direct hydraulic coupling. When you specify that, it'll specify your gearbox ratio as 1, which will then remove all gearbox and other losses from the calculation, which is the way it really is. A direct hydraulic drive doesn't have a reducer on it. It will also set your mechanical efficiencies, so on and so forth, and we can now enter what our synchronous RPM is, or let Sidewinder then calculate that based on our speed and our pulley diameter and so on and so forth, just like a regular conveyor calculation. In this case, the motor RPM happens to be about 18 RPM for this case. So I think that wraps it up for feeder belts, and we'll go from there.